Okay, you've spent a lot of time with linear functions. Now we're going to move on to quadratic functions. And today I want you to be able to graph a quadratic function in standard form. So let's first talk about what a quadratic function looks like. It's a function that can be written in the form of f of x equals a times x minus h squared plus k. And here we need to change this. This says k is not equal to 0. We need to change that to a cannot equal 0. And the reason why a cannot equal 0, if we made this 0 and we multiplied here, that would take the x squared term right out. So the a cannot equal 0. It's okay for k to equal 0, but not a. Now the rule for the quadratic parent function is f of x equals x squared, and hopefully that looks familiar, and hopefully you remember what its shape looks like. Its graph is a U-shaped curve, so it looks like this, and it is called a parabola. Now we're going to graph a quadratic function in standard form. This is vertex form, and we're going to deal with that in section 5.2, but today we're just going to look at graphing a quadratic function in standard form. So before we get started, let's just talk about what standard form looks like. And standard form for a linear function is ax plus by equals c. That's the linear equation. This is a quadratic function because it has f of x, and it looks like ax squared plus bx plus c. All right, now we want to start with the vertex. So we're starting with this point here. When you're graphing a line, you start with the y-intercept if it's in slope-intercept form. But when you're graphing a parabola, you want to start with the vertex. Otherwise, you're just going to be picking random points, and you may just pick all the points that are on this side and never find the vertex. So let's start with the vertex first. And you find the vertex by doing x equals negative b over 2a. And this point shouldn't be right there, so there's no. So let me just write it off to the side here. So it's x equals negative b over 2a. That's how you find the x-coordinate of the vertex. Okay, now you can find the y-coordinate by substituting the value for x. So we would take this value and substitute it back into our original function. And then you're going to graph your vertex. You're going to find 2 points to the left of the vertex and graph, 2 points to the right of the vertex and graph. And you always want to graph at least 5 points. You want the vertex and 2 points, and just insert an S here, 2 points to the left of the vertex and 2 points to the right of the vertex. All right, so let's follow an example here with our steps. All right, here is our quadratic function. We should end up with a U-shaped curve, and we want to find first the coordinate of the vertex. So what we're going to do is we're going to do x equals negative b over 2a. This is our a, so that's 1. Here's b. Remember to take the sign of the number with it, and we don't even have to worry about c because it's only negative b over 2a. So be careful when you have a negative b and the b is negative here. So it's going to be a negative negative, which ends up being a positive. So x equals 3. Now I'm going to put my vertex right here, and you don't have to put your vertex here, but I'm just putting it here because I want you to put 2 points on either side of the vertex. So basically what we're doing, if we have a parabola here, well, let me erase this here. We're picking the vertex first, and then we want to pick 2 points to the left and 2 points to the right. So it'll give us a nice shape of the parabola. So the first thing that we're going to do, we find the x-coordinate, which is 3, and this is for our vertex. So let's just write over here, vertex. And now we want to find the y-coordinate. And if you want to find, remember this is like saying y, so we can just substitute the 3 in for x here and the 3 in for x here. And that's going to give us 9 minus 18, so negative 9 plus 7, which is going to give us a negative 2. All right, we're going to graph the vertex, so we're going to graph it at 3, negative 2. And now we want to find 2 points to the left of the vertex. Now usually what I do is I usually go 1 unit away and then 2 units away. So this would be 3, since we're going to the left, that would be 2 and 1. So 2 and 1. And then if we substitute those values in for x, I substitute a 2 here, square it, and then subtract 6 times 2 plus 7. So that's going to give me -1 for my y coordinate. And then if I substitute 1 in, I square 1, I get 1, and then -6 times 1, and then add 7, that's going to give me a 2 for my y coordinate. All right, so we found 2 points to the left of the vertex. Now we want 2 points to the right, so I'm going to choose 4 and 5. And you can choose, oops, that's not my y coordinate. We want to go 4 and 5. Now you could choose 10, 15, but the problem is the larger your x values get, your y values are going to grow quickly. So you want to usually go 1 unit away from your vertex and then 2 units away on either side. All right, so if I substitute 4 in here, I'm just going to tell you what those values are. It's going to be 4 and then -1. And then I put a 5 in, 5 squared minus 6 times 5 plus 7 is going to give me a value of 2. All right, so let's go ahead and graph the rest of these. We have 1, 2. We have 2, -1. We've already graphed our vertex. So let's just say that this is our vertex here. And then we're going to graph 4, -1, and then 5, 2. And if you plot your vertex and then you choose 1 unit away, 2 units away on either side, it should be symmetric around your vertex here. All right, so we're going to draw a smooth curve. And there's your U-shaped graph or your parabola. Okay, so always find 5 points. You want the vertex as your first point, and then 2 points to the left, 2 points to the right, and you always find your x-coordinate by doing -b over 2a. Okay, you have a graph to try on the other side.